All right. Well, I want to apologize in advance. I'm on my phone hotspot right now. My Wi-Fi went out earlier, so I apologize if things get a little fuzzy. I wish I could be there in person to present, but I appreciate Dr. Anderson allowing me to do this via Zoom. I will, however, be back in South Carolina for the waterfowl workshop at Nemours, and then I'll be in Georgia for the SEFA conference. So if any of y'all are around then, I look forward to catching up with y'all there. Jumping into my presentation here, I wanted to give a little update on the work that I've been doing here in the South Atlantic. But before I get into it, I wanted to go ahead and get some acknowledgments out off the top because I normally get tired of hearing myself talk and brush through this at the end, but wanted to thank my committee members for their help throughout this process. Dr. Lavretsky and Lauren McFarland at University of Texas, El Paso for their help with some of the DNA work in the project. I also want to thank Dr. Rick Kaminsky, Mike Prevost, Craig Sasser, and Dr. Travis Folk for helping me or helping facilitate introductions and everything with landowners and land managers around the area. Funding was provided by the Fish and Wildlife Service and USGS, along with Nemours Wildlife Foundation and the Mississippi State Endowed Chair and Kennedy Endowed Chair in Waterfowl and Wetlands Conservation. The Clements Kennedy Center has also helped facilitate logistics when I'm sampling around the Georgetown area, so I appreciate that as well. South Carolina DNR and private landowners for allowing access on their properties. And last but not least, my technicians for all their help. They helped me get through hundreds of samples in the lab where we sorted through over 180 pounds of submerged aquatic vegetation and have counted over 210,000 individual invertebrates, mostly snails. So it's been quite a bit of work, but it's finally starting to come together. For this presentation, for those of you that aren't familiar, I'm going to give a brief kind of background on the project objectives and how the project got started, and then go into some preliminary findings and my plans going forward. So this project partially stems from a collaborative effort from Ducks Unlimited, the Black Duck Joint Venture, and the Atlantic Coast Joint Venture, who have been working on a large-scale bioenergetics model to improve conservation planning for the American black duck. Because the American black duck competes with other dabbling duck species in the habitats that they use, the model also incorporates 8 other species as well. And here is a look at what that model looks like in a web application that they have. And so basically what it does is based on the amount of food in a given area, it identifies areas that are food limited based on the population levels that we are set by the North American Waterfowl Management Plan. So it identifies areas that need restoration or are food limited. And then it also identifies areas that have enough food, but maybe need wetland protection or land protection in the area or some combination of those factors. Of course, to get to a product like that, there's a lot of different inputs that need to go into that model. For example, you need to know what the birds consume and where they're consuming different prey items so that you can identify where you need to do your sampling and what to sample for estimating food supply. Then on the energy demand side, you need to know, what areas birds are using and how long they're staying there and what the daily energy requirements of those birds are. And so the current model, because the prime or key areas that you find the American black duck is in the northeastern United States. That's where a lot of the inputs for this model have come from for the Atlantic flyway, but are more limited or region-specific estimates don't really exist here in the South Atlantic. And so that's why we decided to focus on a couple of these inputs in the model, such as the what exactly birds are consuming out of the wetlands they use here in the South Atlantic, and then also how much of that food is available in the wetlands. And so to do this work, we sampled in 6 regions in North Carolina and South Carolina, 2 of which were North Carolina, four in South Carolina, those being the confluence of the Black, PD, and Waccamaw rivers, Santee Delta, the Ace Basin, and the Santee rivers. Within those regions where applicable, we sampled 3 different managed wetland types, including managed tidal impoundments, those promoting brackish submerged aquatic vegetation. We sampled moist soil wetlands, flooded crops, primarily flooded corn. So for the first objective of looking at the waterfowl diets, we used 2 methods to get at the food habits of waterfowl. First, we did some traditional collections, which that's where we watch birds. For the diet primarily interested in these 9 species here, but I've highlighted 3 that were the main focus of the traditional collections, just because that's what I had most the most access. You all still hear me all right?
You're cutting out a little bit out there for a minute.
Okay.
Yeah.
All right. Hopefully we're good here. Sorry about that. Okay. Yeah. So as I mentioned, the 3 species I have highlighted here are the birds that most of the traditional, just because that's what I had the most. At those traditional collections, seeds and tubers make up about 50% of their diet by weight, whereas vegetation and invertebrates each make up about 25%. However, if you look at that in terms of energy that they get from those food items, seeds really make up about 63% of the diet. Vegetation still about 28%, and invertebrates just 10%. Here's a look at some of the kind of a key thing to note here is that even though seeds make up the bulk of the diet overall, we did have snails, the vegetation of widgeon grass and duckweed all show up kind of in those top prey items. Here's a look at the breakdown of those 3 most common species in this data set. And here we see some pretty interesting differences between the species. So blue-winged teal were primarily invertebrate-based diet by weight, whereas gadwall were vegetation and green-winged teal seeds. Again, I showed this in terms of energy too. Of course, that invertebrate section just kind of shrinks in all of them. Kind of wanted to note there that blue-winged teal, even though their diet was over 50% invertebrates by weight, that reduces quite a bit in terms of the energy consumed. But it's still important to note that all of these doesn't have a lot of caloric value to the birds. It does provide other nutrients and minerals like calcium that birds need as well. And then finally, looking at the comparison between the traditional methods and the DNA. This is still a very small data set. I'm about to jump back on this portion of the project here soon. But for these 10 birds where we had this direct comparison, we were seeing pretty similar diets, with the exception of vertebrate DNA showing up, primarily frogs and fish. And so I'm going to do some more investigating into that here soon when I get back on the DNA stuff. In terms of the wetland sampling, We were, like I say, primarily sampling those three managed wetland types: SAV, moist soil, and corn. For SAV, we were doing that in late September using rake and here's a red imagery so that you can see the difference between open water areas that are areas where submerged aquatic vegetation would be growing and then emergent vegetation. And what we would do is take 10 random samples within those open water areas to look at submerged aquatic vegetation, seeds, and then we'd also take 10 samples in that open water area. I'd also wanted to mention we take a SAV sample and a soil core paired sample right next to each other in the emergent vegetation. And so what are we finding in terms of duck energy days in these impoundments? Starting out with the invertebrates, if you see, you can see that in open water, you can see that in open water, we have a lot more invertebrate biomass or duck energy days. Duck energy days being the number of days a waterfowl can be sustained in that acre. So like in open water, we're seeing 60. Most of that is from the core, whereas in emergent, that's only about 10. However, when you start to add other diet items in there, like seeds, you see that invertebrates kind of get washed out in that. There's a lot more duck use days in the seed biomass in those wetlands. And then, of course, in the open water areas, you also have the SAV biomass. So in total, in open water, you're looking at about 1,400 duck use days per acre, whereas in the emergent vegetation, it's more about 600 duck use days per acre. In terms of kind of variability among the years for seeds and invertebrates, it seems to be relatively consistent, but we did see some pretty big differences in vegetation biomass. Here you can see in 2021, we had much higher duck use days from vegetation. And that is primarily a factor of how often vegetation was present out there, essentially. So the figure to the percent occurrence of vegetation at our randomly selected points. So in 2021, it was 90%, or we had vegetation at 90% of the samples, 22, 77%, and 23, 61%. And both widgeon grass and muskgrass stayed fairly consistent, whereas there was a pretty dramatic decline in spike rush across the 3 years. So I included this little table down here in the bottom left showing the salinity and pH that we measured just at the time of sampling between those or in those 3 years. In 2021, we had much fresher conditions, so we suspect that's why we were seeing a lot more spike rush during the 2021 sampling season. One other thing that I wanted to look at is I know the Fish and Wildlife Service and DNR have been adopting these rapid assessment techniques for sampling moist soil impoundments and flooded corn as well. But currently, there's nothing out there for rapidly assessing the amount of SAV. So what I did was took field wet weights of the SAV that we collected and see if that was a good predictor of the final dry weight in the lab. And what you can see is that it is a pretty good predictor of that. We did have 24 samples that I noted in the field had a lot of algae and other debris mixed in. So I removed all of those samples for consistency. And you see that it is a strong predictor of the final dry weight. The next question, though, is if that field wet weight is also a predictor of the final for that sample point. So if including the amount of seed biomass and invertebrate biomass, can also be predicted. And that's what I'm going to be working on next as I compile all this data. So how does this fall back into that initial model that I brought up? Here's a look at the different wetlands that we sampled and what they're classified as in the bioenergetics model, along with the duck use days that are applied to those values in the current model. Our findings are so for managed tidal impoundments, that should be classified in their model as managed aquatic bed. That kind of fluctuates a lot based on how the National Wetlands Inventory classifies things, but that would put it at about 1,600 duck use days per acre. Our findings for the open water areas show about 1,400, so pretty similar. But if you incorporate those areas of emergent vegetation where there is less food and just impoundment, you'd be looking at more of about 1,000 duck use days per acre, or 34% decline from the value currently used. The big one to note here is the moist soil, which in the model is managed freshwater marsh. They use a value of about 2,400 duck use days per acre. But what we were seeing from our rapid assessments is really less than 1,000 duck use days per acre here in the South Atlantic. Again, those current values in the model rely on a lot of different areas in the country. So some of those values that are included in there come from the Mississippi alluvial valley and also the Midwest, where they have a lot higher moist soil production than we do here on the coast. And so that's kind of a big area where we would see a lot less food on the landscape using these region-specific estimates. And then finally, corn, they're using about 20,000 duck use days per acre, where we were seeing about 30, so 50% increase. They incorporate other crop types, including soybeans and rice, in that 20,000 estimate. So if you just looked at corn, it would be pretty similar across other regions of the country. So what's next? Kind of the next thing on my agenda is I'll be going to the estimates across wetlands and the stuff where have food left suggests. However, it's still up in the air whether or not there's any areas that are food limited. But forward, we can use these updated estimates to inform waterfowl conservation in the region by seeing if there are any areas that are food limited using these updated inputs. But more. So again, I apologize most of that, but I appreciate y'all's time, and I'll take any questions